Hello, everyone, and thanks for joining us this summer for our first in the middle of summer uh, Emerging Science of Anaerobic Digestion webinar. This month, I'm excited that Keith Webster from the Digital Ag team here at Iowa State is joining us. Keith has been looking at some of the supply chain logistics, both for anaerobic digestion, as well as some of their history with other biomass accumulation projects. And I think one of the things we've seen and talked about here is scale gets to be really important. And while we have a lot of manure in the Midwest, finding ways to get these projects to be a little bit bigger, a little bit more material to digest is sometimes extremely important. So excited to see what Keith has to say about the potential for biomass aggregation and how that might fit in some of these systems. So with that, Keith, I'll hand it over to you and let you give a little introduction of yourself and then get us rolling for the day. Hey, Keith, are you there?
Yeah, heck
There
of a
we
way
go.
to start things off. So sorry about that. Uh,
Perfect.
so thank you for the introduction, Dan, and welcome everybody in the group. I hope you can walk away with maybe some little bit insights from some of our work that we've done here in the last few years in biomass supply chains. So kind of kick things off and there we go. So a little brief background on myself. So I've got 15 plus years of experience in commercial biomass supply chains, basically looking at every uh, conceivable size of supply chain that you could think of and a lot of various feedstocks. If you think about Iowa, you think about corn stover, but you even think about cover crops or alternative crops from there. We've kind of looked at that, and as you start to apply some of the basics rules around what biomass is. Um, these rules are shared across multiple feedstocks. So got a lot of experience there. On a personal note, I grew up and still help manage a diverse multi uh, crop farm back in central Illinois. So had the livestock and things like that. So I've got beyond my experience here in different supply chains. Spent many a summer baling hay and putting small square bales into the barn. So have a personal level of experience from that regard as well. So let's look at maybe a quick little overview of kind of what I want to discuss here, and just maybe where we as an industry have have been steered over the last 30 or 40 years here. So, as many of you probably know, Iowa has been one of the leaders in the industry in developing in helping in innovating these conversion processes for biomass crops. A lot of the policy that was laid out in the early part of the century really paid off as the cellulosic ethanol uh, uh, phase went into the industry with all that with investment from from the public there. So um, back in the 2010s, um, in Iowa, there were two cellulosic ethanol plants that were built, Poet and DuPont cellulosic ethanol. Nameplate on those uh, plants were about 1 million ton of residue that was supposed to be consumed by those plants on a year by year basis. And one thing that with those plants, as they were being built, the supply chains had to be built along with them. And if you've paid attention to Iowa, it's a lot of corn and soybeans, and not a lot of experience was out there amongst the public of, well, how do we operate a large supply chain that is focused on biomass? It's a completely different beast when it comes to how you handle, how you transport, how you manage that material. Even as simple as things about, how do you operate a baler or a harvester in order to collect that material. So there was a lot of education that had to come along as those plants were being built, and that was developed. And the thing that really kind of is forgotten in those operations is that the plants were built, but the supply chains had to be built, almost a year or two ahead of them in order to make sure that they were scaled appropriately when the plant was operational. So, really, we got to operate some fairly large supply chains uh, uh, in the mid 2010s as these plants were starting up. Um, as policy and economics changed, the cellulosic part kind of fell to the wayside, but several smaller projects really have prevailed beyond those projects today and have stood on what the principles from those projects that um, were built upon. And so, there's several smaller projects, throughout the state and through the Midwest that really, are taking the next step and helping build a more solid supply chain up in the state of Iowa here. So, on a basic, just where I want to head with this presentation today, feedstock supply chains are the critical point of success for a conversion process. The feedstock quality is going to dictate a lot of the conversion challenges that are come along with any conversion process. Obviously there's a cost associated with collecting this material, and it has to make sense to go out and put that effort forward from there. And then there's this production expectations that are the realities of what a supply chain will have to go through. And so I'll try to talk through some of those. And if there's any questions along the way, I'm sure that they can get up to me and we can talk through here later through the presentation. So if we just start with just a basic supply chain overview, if we want to look at maybe just some principles of where we're of a supply chain. So the one thing that I like to really educate people on is a step in the supply chain is likely going to involve a person and a machine. That's the most simplistic way of putting that concept. A person and a machine for every step. And I do that because that is a cost associated with that person and cost associated with that machine. Um, and with that, you have the ability to have um, uh, businesses and opportunities start to present themselves to individuals for participation in that supply chain. Depending on where the scale is, a person could ultimately decide to build clear into that, specializing in that task, or they could choose to involve multiple processes along the way. It also provides opportunities for individual growers who may choose or have the equipment on hand to participate in individual steps with the supply chain to provide feedstock to a facility, whether it be a anaerobic digestion or anything else. So there's several ways to build that and opportunities out there for individuals to grow into a supply chain like that. One of the other things that I really try to stress in these supply chains is most of your optimal biomass harvesting times are when there are critical periods in the cash grain uh, growing times. So typically within planting or within harvesting, that is when the critical harvesting time for biomass is. So what I really stress there is that especially out in rural areas, you're going to have uh, really constrictions on what equipment's available and labor, and so you're going to have to really compete in those areas to pull labor forces out for this, but that also produces opportunities for people to come in and participate that may or may not have had an opportunity to. In case of going back to the Poet and DuPont supply chains, I witnessed several sons and kids come back from to the farm and form their little baling business or form their biomass moving business and help with the crop at home, but then also come back and bale um, dad's farm or the neighbor's farm or something like that in order to get a little supplemental income and get their feet under them as they build a business. So there's those opportunities, but it's also a reality that it's a time when labor is going to be very tight, equipment is going to be very tight, and we have to keep that in mind as we scale these supply chains. So on a base level, there's about 5 steps to a supply chain, and I lay them out here basically for you. So you're going to have your contracting with a producer or grower on no matter what feedstock that you end up choosing to use. You'll end up agreeing to come in and buy that material from him. Um, Beyond that, you're going to end up having a collection step and then ultimately try to store that material and transport that material ultimately to the plant gate, to the pre-process side of the plant. And I highlighted those three steps in the middle because on a simplistic view, that is they are 3 steps. But in reality, and as we move forward here, those steps really multiply out into multiple steps. And kind of coming back to that the concept where it is one machine, one person for every one of those steps. And that's where you really start to have these steps, multiply out and build that cost into the supply chain. There are some steps here that, when we first started looking at supply chains, we never even had a concept that we'd have to a supply chain. Primarily I'll highlight, we never thought we'd have to come back and check a field for twine or residue removed as we have a step now laid out in that field. But enough grower pushback from producers who would plant the grass crop back into a field the next year that they would have twine and other things wrapped up in their planters basically dictated that that is a step that had to be introduced into the supply chain. So I guess the driving home point here is that yes, they're very simplistic in nature, but they can get very complicated very quickly if it is necessary or if you have to have them in that step. So, what are some labor requirements for biomass aggregation? I borrowed this slide from another presentation that we did in which we were looking at prairie harvesting for anaerobic digestion. And I laid this out on if we were to harvest 1,000 acres of material, what would that uh, labor requirement look like? Labor machine requirement look like? So you can kind of take two different paths with this. One is, look at a baling supply chain in which you bale a material, move it off to the field in that regard. Or you can look at forage harvesting, in which you chop that material and then haul it off to a pile at the conversion facility. And really, there isn't a lot of differentiation between windrowing and collection. for machines and labor. Where the differentiation really starts to build up is when you start to transport that material. In transport is transportation is a very um, sneaky, I guess I'd call it, step in the supply chain in which you can really start to build up heavy requirements for trucks and stuff, and support vehicles to get that material away from a machine and keep that machine at peak efficiency. Um, and so you really want to, take that into consideration as you start to lay out what is the kind of the pre-process requirements uh, for your supply chain. And it's you know, here I would admit that, you laying this out, looks like one is maybe better than the other. But then on the other hand, if you make a bale and you have to break it apart at conversion facility, you have to be able to break that bale apart consistently at the facility. And so there's trade-offs there, and uh, converting, that material, or converting that bale back to a bulk material, isn't a step that ultimately want to overlook. It's just something that you really want to make sure that you have a good process on hand in order to do it. So let's transition now over to looking at harvesting. So, some basic principles here that I really, want to convey here is that, if you want to look at harvesting, I would look at it almost as a factory, because it truly is a factory on wheels when it comes to the harvesters today. Some basic principles that we really look at is, people and personnel can only work so long throughout a day. So you're going to be limited on, what is a base working load for the harvesting crew. Um, Machines will have a maximum throughput, so much like a factory would. They're going to put so many, trinkets and stuff out throughout the day. But where you have a differentiation is that from a factory is where they have a more controlled environment, controlled expectation, in which you can have a consistent throughput in and out. Crop and weather settings really dictate how your working hours and that throughput for that machine is going to be. So one of the ones that we really had to get an understanding, one of the traits that we really had to get an understanding of is what is the potential working days uh, in in Iowa for harvesting, um, because really that was the first start to helping size the what you could have for a fleet of machines to harvest. So I've highlighted here kind of the three potential area crops that kind of hit in unique time periods through the season. With the rye being a cover crop, um, uh, uh, feedstock, which would come in the early spring, prairie, which would be a crop that would come in mid to late summer, and then corn stover, which would be in the fall for harvesting. And so I guess really the driving home points here, what I wanted to highlight is that in the spring, in the typical wet periods that we have, rye, you really have limited time periods in which you are able to go out and be able to harvest. So, in most weeks of a rye harvest, you're going to have about 4 days to be able to harvest that per week. And as many of you know, with spring, those rains could be very sporadic. It could be a day or two here, a day or two there. It becomes very challenging for a cover crop to get that material to dry, and get it into a usable form for a conversion process without involving some sort of ensiling process for that. So, it, drying would be a wonderful step to or way to remove an ensiling process and ensiling cost for that supply chain. But on the other hand, you don't have the luxury of having multiple days to uh, remove and dry that material um, for for that crop. Often there's a cash crop that's coming in behind it, often soybeans, but a lot of producers will allow a few days to for removal of that material, but multiple days would probably be a hard time to get that producer to wait that long to remove that material. Prairie and corn stover all have a lot longer or more active, more possible days in the week to harvest, especially prairie where you're in the middle of summer with longer daylight hours and things like that. Where you start to run in to challenges there, uh, especially in the corn stover side, is as you start to get later and later in the season, those days really start to shorten up and get more sporadic, and you really start to have challenges with if you have weather events in October, November, getting that material to dry out in a timely manner or is something really to watch. So that's just something to keep in mind as you start to lay out, what would be fleet requirements for machines and stuff like that is the active field days. So you combine that with what your throughput would be, and I pulled this data from data that we had from Cornstover. Um, there's a time period in which you're going to be able to bale that material in a day, and with machines, and especially in the ag environment, they're gonna have challenges. They're going to have to stop and repair, unplug machines, uh, and fix machines from there. You're going to have to move fields, and then you're going to have to make sure that that material is also within spec. So, a typical crew, a typical operator of a baler will probably put in a 12 to 15-hour day for maintaining and operating that baler. But what we found in our research is that when that baler is actually baling, so if it's moving through the field with the baler being operational, it's only about 5.3 hours per day that they're able to make bales. And that's, you've got, and that's got to be spread out over several hours in order to achieve that operational success for that machine with that. When when we were looking at what a throughput for a baler could do, we were targeting about 300 bales per day for that machine. So that would be about 150 dry ton of material for that one baler per day. So in a feedstock or in a supply chain where you have um, you know thousands of tons of feedstock that you're trying to collect, you're going to have to have a longer operational window so that you can limit the amount of balers that you're going to have, um, or you're going to have more balers in order to achieve what you're hoping to collect for that material. So one thing, these numbers are focused around corn stover, um, feedstock type, and then your locale. So if you're in the Midwest versus in the in the Southwest or in the Panhandle, of Oklahoma, you will have different uh, time periods in which you're able to bail, um, and um, and that could help vary these numbers just a little bit. But in principle, these are good target numbers to work with as you're setting up your supply chain. So I talked a little bit about, what a baler operator might have for working hours. And I think this is a good principle to work with just, for expectations. Most crews will end up driving to the field, by 7 or 8 o'clock in the morning. They're going to basically prep their machines for work, and then by 9:30, 10 o'clock, they're going to start trying to step in and try material to see if it's going to be able to bale. Over that next hour, they're going to be able to basically establish that the material is ready to bale, and then they're going to start into that 5 hour window of production in which they're going to be able to produce their bales. And so by 5 or 6 o'clock at night, with success, they're going to have that 300 bales produced. And then ultimately, by the end of the night, conditions will basically limit how far they can run into the night and then basically be on their way home. But I think this is important to highlight that, as operators go, they're working a pretty full day in order to get this material um, collected. So so yeah, so that's kind of where the harvesting, I guess, aspect for operators and crews come in. So let's touch a little bit more then on the quality aspect, since I talked a little bit about with crews monitoring field conditions and crop conditions with that. So there's kind of two levels of quality that we really look at in a supply chain. So the ash content is definitely one that we really are mindful of, because if you're hauling a lot of non-convertible material into a conversion process, you're having to haul that convertible material back out. So it's cost in, cost out. Um, it's a favorite picture of mine. A colleague of mine in one of our first years actually found that rock in one of these bales. So you can only imagine if that entered into any feedstock stream, what that would end up doing to most processes. The main principles with the material is that you want to collect that material in the most pristine condition that you can, and you want to maximize that condition as long as you can. So you want to minimize the dry matter loss content. So you want to minimize losing any material that you collect, which will ultimately add to your cost. So what is the ash what is ash? So basically ash is dirt or non-combustible material in that feedstock. For corn stover, it's a lot of dirt. For other crops, it could be rocks, it could be anything else that ends up in that feedstock stream. But you just want to be very mindful that you have controls in place in order to make sure that a lot of this ash and dirt are not making into your stream. With corn stover, one thing that we really found, and we kind of have talked through with several groups, is um, that it really is dependent upon collecting high yielding crops as you start into your processes. So on the screen here, what you see is basically a relationship between, as you increase your harvest rates, you are driving the ash content of that material down. So basically, higher quality material, more of it, reduces that soil interaction of the equipment, and reduces the amount of that material that you would end up in the windrows, and ultimately into the feedstock that your harvest or you're collecting for conversion. So, when you are going out and selecting fields, selecting those high yielding potential fields are really a benefit to not only your process for having more or less fields to harvest it from, but you're also improving the quality of that harvest. The second part with the quality aspect, and I just put up a picture here because this probably speaks volumes to preserving feedstock quality. So there's multiple ways here that this bale stack has failed, in which I wanted to demonstrate. So there was a failure in this bale stack by not being able to have the cover protect that material. So you saw rainfall enter from the top, which is the streaks down through the bales there. This material also had a lot of high moisture in it, as you can see the contamination of the feedstock from the top. So they were rotting basically as they were sitting in that uh, pile as well. And then uniquely on the bottom, one of the other things that we really found is that bales really will help draw moisture out of the ground. And so there is a lot of on the bottom here. That is a half of a 3 by 4 foot bale that basically had deteriorated over the course of the storage period. So basically, you're losing your feedstock in several ways as you store it. So having the discipline and having the investment to really make your storage successful will help your feedstock quality stay at a good point throughout the harvest or throughout your supply chain. So kind of the final discussion here maybe to talk about would be on a cost standpoint. So from a principles point here of the supply chain cost, one thing that we really in the last few years have tried to drive home with this is all these steps in the supply chain. There's going to be margin that these businesses or these steps all have. Everybody not necessarily wants to make a large margin, but they want to be make a little profit. Typically, we figure anywhere from 10 to 20% profit, and that's it up to an individual decision point of where their profit wants to be at. But that margin has to be accounted for in your supply chain costs. And so, in most of these supply chains, we can get costs to, $100 per ton, but you really need to build in that margins in order to, account for the people that are going to be participating in that supply chain. So that's, one of the points that, I think we've really tried to stress to people considering these supply chains to build that in as well. And then there's some methods that we've looked at for overall cost reduction. The most obvious one would be to eliminate steps in the supply chain. If you can minimize transporting the material from a field to the directly to the conversion facility, you're removing steps for in the transportation process. So there's things there that just help you eliminate costs altogether. I touched on it earlier as far as convert in the quality aspect of things, in which you want to maximize your yield. You know, that minimizes the amount of fields you have to contract. That minimizes the ash that ends up in the material. And so, you want to select fields, select areas, select crops that really help you um, get the most material from your area. And then, like I said, with quality as well, you want to protect your loss from dry matter. Um, because as you lose material in a storage process, there'll never be any more better material, more potential for that material to be converted than when it is made in the field. For every point in that step, supply chain process from that, you're losing dry matter, you're losing yield, you're gaining costs of that material. And then one that we really kind of drive home ourselves is that density of that product matters when you're moving it beyond the field. You really can balloon cost by having by trying to move a bulky less dense material. So any way that you can improve the density of the material that you're trying to move will eliminate costs, not only in the transportation step, but in the handling processes and then also in the storage processes. So there's there's ways there that if you can help your density, you can help costs as well. So high level, costs here, if you had to throw what were where your costs would be at, your largest cost is always going to be in the collection process because you have the most machinery that you have to deal with in that process. Um, there. The next cost, and it's going to be a little bit more variable, is your transportation because ultimately, if you're transporting at larger distances or unable to fill trucks to their maximum weights, you're causing more costs to be built up there. And your storage costs are going to be there, but ultimately, no matter where you have that cost, have that material stored, that cost is typically going to be fairly stable at at that at that point. So that cost will stay a little bit fairly stable and be one of your smaller costs. But it's an important cost because if you don't invest in your storage, you'll lose the most potential of that material. Ranking the factors of cost would basically be, and this comes back to where my discussion around density and harvest rate. We looked at this early on in our supply chains and really looked at and delved into what would be the factors that if you had to reduce cost and you had to um, if you had to reduce costs and and make the biggest steps, the density of the material and the harvest rate of that material can help eliminate the most cost out of your supply chain uh, in the fastest ways. Everything beyond that in these steps really start to have less impact on cost. They can have impacts, but they'll have less impacts. And I think the other thing that's important here is if you start to go the other way, so if you have less dense material, if you have lower harvest rates, you can have the highest impacts on your costs as well. So that really, factors into the overall rankings of how this cost really plays out. So that's kind of a very, I call it, high level overview on things on that. But that's kind of a good discussion where where you have. So Dan, I think that would be where I would end up with, and I would be happy to take any discussion beyond this.
Perfect. That's great. Thank you so much, Keith. And we do have a couple questions for you. The first one was, do you have a recommendation for maximum stover harvest rate? And do you have a relationship for stover harvest rate and cost? Maybe does more stover per area reduce cost and how much by how much, I guess.
Yeah, so yield on Stover, we basically were right around 2 ton per acre. Is where we kind of figured those would be, and that's going to be a little bit of advanced field scouting so that you're able to go out and select those high yielding, high producing fields, so that you're able to maximize the cost there. Um, so that would be kind of the numbers there. And then the second question was the cost of Stover to price ratio. What was that?
Yeah, this maybe the cost related to how much you're harvesting. If you could harvest more per acre, do costs go down per bale or acre? How would that work?
Yeah, so it would go down a little bit. So like I said in those last that last slide, it's a smaller relationship there.
Mhm.
There's bigger factors as far as the density aspect of things, but there would be reductions, yes, in cost by getting because you're just you're running the machines less, they're more productive in those fields. You're having to run them to less fields in order to to get the same amount of stover.
There's nothing worse than having to move equipment all over the countryside to get done,
Yes.
to get everything you need. Another question we had is density always the limiting factor on hauling? How often do semis hit full weight and sort of what's the trade-off there between it's a maximum volume?
So there is probably a so the trucks very rarely, when you're hauling dry material, very rarely get uh, maxed out on weight. It is always a volume before weight. Now, the one caveat there is if you are starting to haul weather material, hauling that moisture, you can start to maximize the truck weights. So that's the one caveat that you have to watch. Now, if you're hauling weather material, then you have problems at the storage point. So, really managing that moisture is important for not only transporting, but for your storage uh, as well.
Mhm. And then if I harvest silage, then I can sometimes max out my truck weight. Is that right?
Yes,
Yeah.
yes,
Nothing like hauling water around. And in
yes,
that question, you mentioned you put a bunch of small squares in your barn as a younger
yes.
individual, and I got to do the same. And one thing I contemplate on this area is dairy farms these days often choose silage over dry hay. Uh,
hmm
is there anything to learn from why dairies pick silage over hay and when, and how is that translated to the biomass industry?
Yeah. So I've always looked at that as, I look at it from maybe a palatability standpoint,
Mhm.
and feed more of a feed nutrition. So you're capturing your nutrition and your uh, your feed value better in silage. I've always felt like that was probably a better way there. Um, you know, so that's kind of maybe why I think dairies have kind of chosen to go that route. And they use more of a mixed ration that they really want to control there as well.
Yep.
So the from the aspect of that regards, that's I think why maybe they have gone that route.
Mhm.
I'd be limited to say that I have my knowledge in dairy is uh, uh, pretty limited, but that's kind of my viewpoint, I guess, from the outside. So
Yeah, and I tend to agree with that. I think, but a digester is a big mechanical cow to me in many ways.
it
I'm trying to
is,
mimic a
yes,
cow's stomach, so that's a reason to think that silage might help me digest things better. But there's a trade-off from your harvesting of that we saw.
there
Yeah.
is, yes, and that's the trade-off. That's the decision points that have to be made within the supply chain, each supply chain there.
hmm And getting material dry is sometimes a challenge. It's much easier
hmm
to wilt it a little bit and then silo it if the weather doesn't look
Correct,
good. So it's sometimes a nice
correct.
option,
Yes,
but it's something you have to prepare for. I know for a while people were trying to do some research on single pass corn stover harvest systems. Did you ever get involved in any of that? Is there
I
potential
I
there?
yes, I was the single pass corn stover harvesting guy. So
Mhm.
yes, we did quite a bit of work there. One thing we learned in that regard, it is a viable process mechanically. Like that is a process that can be done. The problem is in corn stover, any ag residue, that's the waste to the farmer. And so you are asking the farmer to potentially slow his machine down, his combine down, slow his entire harvest down in order to harvest a waste material. And ultimately, his share of that cost is, or of that the return of that his pro profit is, maybe 10% of his total revenue for that field.
Mhm.
And so you're asking him to take a 10%, or give him a 10% reduction, or excuse
Return.
me, it's return for potentially what might be a 20 to 30% reduction in his harvesting pace. Some producers just don't think that's a potential or a profitable venture for them. So they would elect to not do that. And so the equipment companies really kind of recognize that, and that's why I think that's fallen to the wayside. You also do, when you are direct harvesting material like that, material moisture could be an issue, and so that grew into more challenges in managing that material that way. So giving that material an opportunity to dry has really given away to more favor than the 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 ash content reduction that you might see with single pass.
Mhm. Perfect. And then we have another question related to sort of hauling distance. Uh,
Sure.
they had always thought that haul distance would be a major factor in price. But since it's handled so many times in that harvesting logistics, is there a big difference in, say, 50 miles or 100 miles or 2 miles, 200 miles? And because you have to get it on the truck. And then on
Yep.
some of these biomass projects you've worked with, what is the distance from from the field to the conversion facility, whether it be a digester or cellulosic ethanol that you've seen people try and achieve?
Yeah. So the answer to the question about the mileage part, um, it is a fact is a factor of miles hauled. So every you are charged basically on a per loaded mile cost. So it's $1, $2, or $3 per loaded mile. So every mile you get away from a facility, basically that cost is going to increase, because your miles are increasing. So whether you're hauling it 10 miles versus 30 miles, from a handling standpoint, no, there's no difference. It's just literally going to be the cost to run that truck that extra mile, that extra 2 miles, whatever it is. Um, you know, in the supply chains I work with, uh, about the maximum mileage that they were trying to get was about 50 is where they started, and then they tried to shrink that radius in, because ultimately you get more turns of that truck if you're going shorter distances. So getting fields closer to your conversion facility is definitely a benefit there. Um, and then they were also not trying to, they were moving the material to a satellite storage location, but they were trying to get away from that in order to reduce the handling plus the truck trip from in that intermediate step. So leaving the material at a field edge was more cost effective than trying to move that to an intermediate step, or step in the supply chain.
Perfect. And then I think we have one last question
Sure.
for you. And you pointed to sort of the labor and seasonal demand challenges. If you look for hope or optimism in that, have you seen any possibility of personnel or equipment sort of moving with harvest windows, or what's the potential for autonomy in some of this equipment?
Yeah, I figured I might get an autonomy question. Um, so I I think so it is done today that crews move with the harvest. There are businesses out there that move from Oklahoma to the eastern seaboard to bale material. So there is opportunity to bring that expertise in. Now, if you are able to build that expertise locally, that is going to be more cost effective because you aren't having to put those individuals and the operators up in the hotel or anything like that and add that extra cost that way. Um, so there are ways to do that. Um, as from a autonomy standpoint, there are there are there are opportunities to automate different processes. I believe for bio actually is running a autonomous windrowing machine with an Ames-based company called Sabato. So there's opportunities there to do some of that work. But I do still think you have to have that people aspect. When something stops, they have to go out and diagnose and fix that. Um, I think there's ways to use technology to help mitigate some of the steps, but I don't know if you're gonna completely eliminate people or machines from that step with autonomies with with autonomy.
Perfect. Thanks so much, Keith, for sharing your expertise and experience on this subject. It's definitely something that hopefully we'll get to touch back to you again in the future. And then I have a few logistics for everyone. Our next webinar is scheduled for July 8th, and we are going to get Raceline Alternative Energy to talk about some of their experiences installing covered lagoon digesters on swine farms in the Midwest. If you know a friend who wants to see this webinar, our past webinars. We do post them on our YouTube channel, and I will share a link in the chat. So if anyone ever needs to get there, you can go ahead and find our YouTube channel. We make slides available if our presenters are willing to share. So I'll see if Keith is willing to share some of his slides after this, and we'll get them posted. And when they're ready, they'll be in that SciBox right there. And then my final one is we have started an anaerobic digestion newsletter. If you are interested in receiving our newsletter, the first issue should come out this month. This link will take you there for sign up. So with that, once again, I just wanted to say thanks, Keith. That was a lot of great information on something that I think digester companies are starting to get more interested in thinking about how it fits with their business. And we really appreciate you sharing some of the expertise you've gained over the years on these different projects. All right. And
Thank
everyone
you.
else, thank you for joining us today. It was great to have you again, and hopefully we'll see you in July. Thanks so much, Keith.